Hello guys, welcome back to Infinite Inside Geometry, lesson 4.1, Parallel Lines. Alright, let's begin. So, we're done talking about congruent triangles and how to prove them congruent and all of their basics and etc. Now we're going to go to another important part of geometry, which is parallel lines. So, and it starts with this question: how can we establish relationships between two lines? We have two lines and we want to find out their relationship with one another. We can divide them into two categories: coplanar and skew. Coplanar lines are lines that are on the same plane, while skew lines are lines that are not on the same plane. For example, if you had a paper and drew two lines, just any random lines at any angle, those would be coplanar lines. But if you drew two different papers, they would be skew lines. Now let's say on that paper, in that plane that you just created, you have parallel lines and intersecting lines. What does that mean? Well, we have already talked about intersecting lines. They're just two lines that intersect at a point. But what about parallel lines? Well, parallel lines are lines that do not intersect at any point, meaning that you can extend them infinitely and they will not intersect at all. They are perfectly straight with one another. An example would be, let's say, two opposite sides of the road. You have one side of the road and the other side of the road. They both have sidewalks, right? Those sidewalks would be parallel because they would not intersect with one another because they're on different parts of the road. Well, what about intersecting lines? How can we split that? Well, we can say that they are regular intersecting, meaning that they just intersect at a random point and make random angles, or they could also be perpendicular lines, lines that intersect at right angles, meaning that whenever they cross, perpendicular lines make 90-degree angles on all four of its angles. So, we've already talked about intersecting lines and vertical angles, right? We've already talked that vertical angles have to be congruent to one another, right? And adjacent angles, since they're on the same line, they would have to be supplementary. Well, perpendicular lines take those supplementary and split them into 90-degree angles. 180 degrees equals 90 degrees plus 90 degrees, aka 4 right angles, which makes them perpendicular. Alright? So, those are the only definitions for lesson 4.1: skew lines, coplanar lines, parallel lines, and perpendicular lines. You will see all of these lines come up in future lessons. But what can we do with them? Well, this unit will all be about parallel lines, so what can we do? Parallel lines are special because they never intersect, even if you extend them infinitely. Meaning that even if you extend them all the way to infinity, they will never intersect, not even once. No point will be the point of intersection for parallel lines. And they make up some of the most important postulates and theorems of geometry. But first, before we can see what some of those postulates and theorems are, we have to get some symbols real quick, because these symbols will be really important when we talk about parallel and perpendicular lines. That is the symbol that denotes two lines parallel. Line M is parallel to line N. That symbol denotes two lines perpendicular. For example, line M is perpendicular to line N. Alright, let's take the first postulate, one of the most important postulates of geometry, the parallel line postulate. For any line and any point not on the line, there is one line that is parallel to the line and crosses a point. If you want to try this out, just draw a random line and a point on a piece of paper and try to draw a straight line that does not intersect the line but intersects the point, meaning that they're both perfectly straight. There is exactly one line that does this for every point that is not on the line. And we can see that this makes a lot of other theorems possible too. such as the shared parallel and shared perpendicular theorem. If line A is parallel to line B and line B is parallel to line C, then line A is parallel to line C. Shared perpendicular theorem. If line A is parallel to line B and line A is perpendicular to line C, then line B is perpendicular to line C. Meaning that if you want to try this out, just get a piece of paper or just write on the paper that you already have. If you want to draw 3 lines and see that if they're all parallel to each other, if 2 lines are parallel and another 2 lines are parallel, then the other pair of 2 lines will be parallel. And a shared perpendicular also has this. If you have 2 lines parallel and you want to draw a perpendicular line in through one of the lines, then that line will also cut the other line at a perpendicular angle. Now, the other theorem on this page is the distance between parallels theorem. This denotes the distance between 2 parallel lines. This is important because usually when we talk about lines, they usually intersect. They're most likely not parallel. Most of the lines that we've been talking about so far have been intersecting lines. And they don't really have a distance from each other because they always intersect, and if you take 2 points on the line and 2 points on another line, they will always be different. And even at the point, if you take the point, the length there is 0. So there's no length to measure there at all. But parallel lines are different since they never intersect. The distance between them is congruent to any other distance that you will measure along that line. And the distance between 2 parallel lines is the length of the segment that is perpendicular to both lines and has endpoints on both lines. So this is a borrowed from the shared perpendicular theorem. You have 2 lines parallel and you draw a perpendicular line through them, and then since 2 of those endpoints will be on that line, the segment that has the endpoints on both lines and is perpendicular to both lines is the distance. And you can do this for any point on a parallel line, and then you get the other point on the other side. You draw a line, and you draw a segment, and there's the distance. And this will be standard. This will be congruent for every single part of the parallel lines. And that'll be all for today's lesson. If you liked the video, please like and subscribe. I may email down below if you have any questions, and I will see you all next time.